in this lecture we discussed how we can traverse the linear data structure, means the arrays. The operations we can perform on linear structure is we can traverse the structure since the elements are stored in sequential memory locations. So we can easily traverse the linear data structure. We can search, we can find out the position, the element in a linear array. We can insert or delete the elements from the linear structure, means if we want to insert the element at the beginning, in the middle or end, we can also do that. We can arrange the elements of the array in any order, in whatever the in ascending or descending order, whatever in the order you want. We can merge two lists into a single list. So traversing is accessing and processing each element of the data structure exactly once. Means if we talk about the linear array process, traversing is you want to visit each and every element of the data structure exactly once. So the if you want to visit each and every element of the data structure, we have to read the each and every element of the array one by one. So we start from the beginning, from the lower bound, and we move to the up to the upper bound. And whatever process we want to apply, either we we want to add some number to the element present in the array, we want to subtract, or we want to print some element from the array, and that is called process. It is up to you whatever you want to do with that element. So the algorithm to traverse the linear array is repeat for k equal to lower bound to upper bound. Here k is the variable from where that range from lower bound to upper bound. Lower bound means the address of the index of the first element of the array, and upper bound is the index of the last element in the array. Since we want to traverse from the lower bound to upper bound, so we start the loop from lower bound. Apply process to LAK, means apply whatever process you want to apply at the k at the element at index k, and this loop will repeat it unless you will not reach the upper bound. Once you reach the upper bound, the loop will gets end and you can exit the program. So if in the form of programming language, this for loop will work like this. We start from index 0. It will take I less than size condition, means if there are 7 elements in the array and the index start from 0, so the loop will continue from 0 to 7. So basically it will work from 0 to 6, and it will increase the counter, and here we are printing the element at the index I. So next is inserting and deleting. So it is very easy to insert or delete an element from the array. So we can perform 3 actions while doing insertion and deletion. You can insert the element at the beginning, you can insert the element in the end, you can insert the element in the middle. Same case with the deletion. So let's take an example at the insertion. Suppose this is the array and the size of this array is 8. So if you want to insert the name Ford at the end of the array, since we have space available in the array, it is easy. Without doing any changes, without making any changes, or without shifting the data, we can add Ford at the end of the array. Now the size of the earlier the size of the array, the number of elements present in the array was 5. Now the number of elements present in the array is 6. But now you want to insert Ford at location 3. So here you are seeing that at location 3 we have data Johnson. If we insert Ford here, we will lose this data Johnson. So we want to insert Ford into this array without losing our data. So for that we have to shift the elements downward. Since I'm saying downward because at the upper side Brown and Davis are already there, and though there is no space at the above side. So the only option we have, we will shift the elements downwards. So at Wagner will shift to location 6, then Smith will shift to location 5th, Johnson will shift to location 4, and now we have location at 3 is we have the space at location 3 is empty. Now we can insert 4 here, but since in this array we have the space available, the array was not full. But if the array was full, it will become it was not possible to insert 4 without the loss of data. So insertion is not possible without loss of data if the array is full. So the algorithm for insertion is here. LA represents the name of the array, N is the total number of elements present in the array, or we can say total number of elements in the array. K is the index at which you want to insert the item. So LA is a linear array with n elements, and K is a positive integer such that the value of K is less than n. So we have the restriction. If you want to insert the element in the array, it's the index that you want to mention at which at the position you want to enter the array must be less than n. This algorithm inserts an element item into the kth position in the linear array. So let's start the algorithm. We initialize a variable j equal to n, where n is the position of the topmost is the position of the last element in the array. So we will repeat steps 3 and 4 until the value of j is greater than equal to k. So we'll set the counter LA j plus 1. So in our previous example, if value of j is 5, since the last element is present at index 5, so if the value of j is 5, then Lj plus 1 is equal to Laj. So here 5 plus 1 means 6. La6 is equal to La5, right? Now this is one loop. Again we decrease the value of j equal to j minus 1. The previous value of j was 5. Now it will become 4. Again we start the loop. So here the value of 4 plus 1, that is 5, is equal to value of La4, means this Smith will get shifted to location 5. So we will repeat the procedure unless the value of j is greater than equal to k. Here k is 3. So when the value of j becomes 3, we will stop the loop. So now the position and the location at index 3 is free, so we can easily insert 4 over there, and the total number of elements will get increased by 1. So the value of n was 5, now it will become 6, and then we exit the algorithm. So same is the case with the deletion. If you want to delete the element at the last position in the array, it is very easy, since we need not to shift any elements upwards or downwards in an array. So if you want to delete Wagner from the last position, you can easily delete it from the last position without shifting any elements, and the total number of elements there will be n equal to n minus 1. So no data item can be deleted from an empty array. So if you want to delete, you can delete only when there is some data items present in the array. If there is no item present in the array, you can't delete any data item. So in this example, suppose you want to delete Davis from the array. The location, the index of Davis is 2. So you can easily delete Davis from location index 2, but now this position is empty. And according to the concept of array, the elements in the array are arranged in sequential memory location. So we need to shift all these Ford, Johnson, Smith, Taylor, Wagner to upwards. So we will shift it step by step. First we shift Ford to index 2, Johnson then is to index 3, Smith is index 4, and so on. So the algorithm for this is, here LA represents the name of the array, linear array, and total number of elements in the array, K the index from where you want to delete the item. So LA is a linear array with n elements and K is a positive integer such that K is less than equal to n. This algorithm deletes kth element from LA. So first we take the element at kth index into a variable called item. So the value of the item will be the variable at location K. Here the location K is the index K is 2. Now we will start our algorithm. So K plus 1, 2. We will assign value to J from K plus 1 to n, means here 2, here the value starts from 3 to 7. Move the jth element upward, means here the value is of J is 3. So LA 3 minus 1 means the value at index 2 will be the value at index 3. The value at index 2 will become the value at index 3, means Ford will get shifted to index 2. So we will repeat the procedure until we will not reach the total number of elements, that is n, and then n equal to n minus 1, means the size of the array will decrease by, the total number of elements in the array will decrease by 1, and then we exit the deletion. So that's all for now. Thank you so much.